everyone, welcome to Lectures by Aparna. In this video, we will discuss how to solve a question from a type of BJT biasing circuit called voltage divider biasing. The video on the theory part of this type of biasing will be available in the description box just below this video. You can check that out if you are interested. Let's move on to today's session. This is the question. I will read it. Calculate the operating point for the voltage divider bias circuit shown in figure. Assume VB is equal to 0.3 volt and beta is equal to 60 for the transistor used. So we have to find the operating point. That means we have to find IC and VCE of the circuit. This is IC, IE, IB, VBE and VCE. So first we have to convert the circuit into its Thevenin's equivalent circuit and then do the analysis. In the theory part video I have explained it in detail how to do the conversion and all that. So let us find the Thevenin's voltage VTH first. VTH is equal to VCC into R2 by R1 plus R2. VCC into R2 by R1 plus R2. VCC is 12 volt here into R2 is 5 kilo ohm by R1 is 40 kilo ohm plus R2 is 5 kilo ohm. So simplifying this you will get it as 1.33 volt. Then find RTH. RTH or Thevenin's resistance. RTH is equal to R1 R2 by R1 plus R2. R1 is 40K into R2 is 5K by 40K plus 5K. You will get it as 4.44 kilo ohm. Now draw the Thevenin's equivalent circuit. First we have to connect VTH, that is 1.33 volt, then RTH which is 4.44 kilo ohm. Then we have to connect this part. This is a Thevenin's equivalent circuit. Now we have to start our analysis. First consider the input section and write the loop equation using KVL or Kirchhoff's voltage law. We have to consider this loop first. So when we go in this direction it is minus to plus. So it is an increase in potential, so plus 1.33. When I reach here, current is flowing in this direction. So it is flowing from a higher potential to lower potential. So when I go in this direction, it is a decrease in potential because we are going from a higher potential to lower potential. So minus IB into resistance here is 4.44K. Now when I go here, it is again a decrease in potential. So it is minus VB. Again here current is flowing from a higher potential to lower potential because current direction is like this. So when I go in this direction, it is again a decrease in potential, so minus IE into 1 kilo ohm is equal to 0. Let this be equation 1. We know IE is equal to beta plus 1 into IB. This is the relation between emitter current and base current. So substituting for the value of beta, beta is equal to 60 here. So it is 60 plus 1 into IB, which is equal to 61 IB. So substitute that value in this equation. So 1.33 minus IB into 4.44K minus VB is 0.3. It is given that VB is 0.3. So 0.3 minus IE 61 IB into 1K is equal to 0. Now take all terms with IB on one side of the equation. We can write IB into 4.44K plus 61 IB into 1K is equal to 1.33 minus 0.3. Therefore, IB into 4.44K plus 61 into 1K is equal to 1.03. IB is equal to 1.03 divided by this value will be equal to 65.44K and you will get it as 15.7 microampere. Now we have to find IC. IC is equal to beta IB. IC is equal to beta 60 into IB value is 15.7 microampere. So you will get IC is equal to 0.942 milliampere. So we got IC. Now we have to analyze the output section. Write the loop equation using KVL. So here VCC is actually connected like this. It is because the positive terminal of battery is connected to 5 kilo ohm. It is plus volt here. So we have connected the positive terminal of the battery here to 5 kilo ohm and the negative terminal to the ground. So VCC is actually like this. So we have to do the analysis like this. So when we go in this direction, it is actually an increase in potential. So plus 12 volt. When we reach here, it is a decrease in potential because current is flowing in this direction from plus to minus, higher potential to lower potential. So it will be minus IC into 5K. When I reach here, it is again a decrease in potential. So minus VCE. Current is flowing in this direction. So higher potential to lower potential. So it is a decrease in potential. Minus IE into 1K is equal to 0. Now IC is almost equal to IE. So substituting this relation in this equation, 12 minus IC into 5K minus VCE minus IC into 1K is equal to 0, which gives VCE is equal to 12 minus IC into 5K plus 1K. That is equal to 12 minus IC is 0.942 into 10 raised to minus 3 into this is 6 into 10 raised to 3. This will be equal to 12 minus 5.652 or this is equal to 6.348 volt. So we got IC and VCE. This will be the operating point or Q point of this circuit. So this is how you solve a question from voltage divider bias circuit. If this video has helped you, please do subscribe to my channel. Also don't forget to like and share this video. Thank you.